Hi, I'm Sarah, and this is Caffeine Extraction, as explained in quarantine. Caffeine is a central nervous system stimulant and the world's most commonly consumed psychoactive drug.
You know, this is, excuse me, a damn fine cup of coffee.
It occurs naturally in tea leaves, cocoa pods, kola nuts, and coffee beans. The goal of this experiment is to explore different variables that affect caffeine extraction and determine which has the greatest impact. We'll be able to see how to better extract caffeine from coffee beans when we brew coffee so society can extract as much of that precious caffeine as possible. To extract our caffeine, we'll use a series of separations called solid-liquid extraction and liquid-liquid extraction. The solid-liquid extraction step is kind of like making coffee, but instead of using a coffee filter, we use a column packed with cotton and sand. We'll collect our coffee samples at predetermined time intervals for the next step. Next, we remove the caffeine from these coffee samples using a substance called dichloromethane, or DCM. Caffeine is more soluble in DCM than water, so it will transfer to the DCM part of our separatory funnel, which we can remove for measurement. The variables we'll be exploring are flow rate and coffee grind size. We will measure their effects on caffeine extraction using a spectrophotometer, an instrument that measures the light absorption of a sample. We'll use these absorbance readings along with Beer's law, which tells us there is a linear relationship between absorbance and concentration. We can create a calibration curve using samples of known concentrations prior to experimentation. The hypotheses of this experiment are that extraction will increase with slower flow rate due to higher residence time of the hot water with the coffee beans, and extraction will increase with finer grind size due to increased exposed surface area of beans for the caffeine to transfer to the hot water. First, we collected data using coarse coffee grounds at varying flow rates. It proved our hypothesis that slower flow rates would result in higher caffeine extraction. Next, we tested different coffee grind sizes at a constant flow rate. The coffee grind size data had unexpected results. We had the highest extraction with a medium grind rather than the fine one. This data tells us that to get the most caffeine in our coffee, we should use lower flow rates and a medium grind size.
I can't tell you how many cups of coffee in my life, and this is one of the best.
But don't go drinking too much. Thanks for watching.